Good day, everybody. This is Dr. Nandi back again. Today, I'm going to talk about a sample problem on Kolmogorov's-Smirnov test for normality. So I'll share my screen with you. So the problem states for 5 sample products, the minutes to failure were 15, 79, 68, 10, and 17. Using alpha equal to 0.05 and the Kolmogorov-Smirnov test, determine whether this sample data came from a normal population. First, we arrange the numbers in ascending order. So the lowest is 10, then 15, then 17, then 68, and 79. We find the sample mean by plugging the data in L1 of the calculator and then stat calc 1, and we get the sample mean of 37.8 and SX sample standard deviation is 32.92. Now each number appears only once and there are a total of 5 numbers. So the relative frequency of each number is 1 out of 5 of 0.2. That is in the second column, relative frequency. Now we calculate the cumulative frequency up to each number. So for the first number, it's only 0.2. For the second number, it is 0.2 plus 0.2, 0.4. For the third number is 0.4 plus 0.2 is equal to 0.6. For the fourth number is 0.6 plus 0.2, 0.8. And for the last number is 0.8 plus 0.2, 1.0. Cumulative frequency is shown in the third column. Then we calculate z-score for each number. Here I've shown you one calculation. For z-score for 10 is sample number 10 minus mean 37.8 divided by sample standard deviation 32.92 is minus 0.84. Next one is minus 0.69. Next one is minus 0.63. Next one, the z-score is 0.92. And the last number z-score is 1.25. Now I find the cumulative area for each z-score. Cumulative area means what is the area under the standard normal curve below that particular z-score. So for example, for the first one, the z-score is minus 0.84. I want to find out the cumulative area, that is area from the left, very large negative number on the z-scale to a right boundary of minus 0.84 in a standard normal curve. So I do calculator on, then I press second, verse, okay, and number 2, normal CDF. My lower bound is a very large negative number, which is minus 1E89. It's already there in the calculator, minus 1E99. My upper is I want to stop at minus 0.84 so that I find the cumulative area to the left of minus 0.84 under the standard normal curve. Mu is 0, sigma is 1. I pressed enter and enter. And that area is 0.2. I repeat the process. So for minus 0.69, what is the cumulative area under the standard normal curve from the large negative number on the left to minus 0.69? Second, verse 2, lower is still minus 1E99. Upper now changes to minus 0.69. Mean is 0, standard deviation is 1. Paste, enter and enter. And that area is 0.245. So 0.245 is the area under the standard normal curve from the lower boundary of minus 1E99 up until 0.69. That is the area to the left of minus 0.69. And we repeat this process. Now we need to find the difference. What is the difference? Difference between the actual cumulative frequency and the cumulative area corresponding to the z-score. So for the first one, cumulative frequency is 0.2 and cumulative area for the z-score is 0.2. So the difference between 0.2 from the third column and 0.2 from the fifth column, cumulative area, 0.2 minus 0.2 is 0. Okay, what about the next one? The difference is 0.4 cumulative frequency minus the cumulative area corresponding 0.245 is 0.155. For the next one, the cumulative frequency is 0.6 and the cumulative area is 0.26. So 0.6 minus 0.26 is 0.34. For the next one, it's 0.8 minus 0.82 is 0.02. I only show you the absolute value. It should have been minus 0.02, but we convert the negative difference into positive absolute difference. And the last one, 1 minus 0.89 is 0.11. So I say the absolute difference, I show with two vertical lines around diff, which is the absolute difference between cumulative frequency and cumulative area corresponding for the corresponding z-score. Okay. And the absolute difference for minus 0.02 is 0.02. Now, if we look at the difference, the maximum difference value is 0.34. This will be our test statistic for the Kolmogorov's Minov test. So our null hypothesis, the sample came from a normal population. Our alternate hypothesis sample did not come from a normal population. Okay. And then we look at the table of critical values of D. D is the absolute maximum difference. For Kolmogorov's Minov test of normality, our sample size n equal to 5, alpha equal to 0.05, the maximum value of D is 0.337. Since the test statistic maximum value is 0.34 is greater than the critical value of 0.337, decision is reject 80. That is, we reject the null hypothesis that the sample came from a normal population. And we can state at alpha equal to 0.05, there is enough evidence to state that the sample did not come from a normal population. Okay, so I will stop here today. If you have any question, please write me a comment and I'll get back to you as soon as possible. Thanks for watching, and please subscribe to my channel because I come back every week with new problems. Take care. Have a nice day. See you next time. Okay.